Hello everyone. Today we are going to learn about the Beers law and the Lambert's law. Okay, let us start. When monochromatic light passes through the solution, the decrease in the intensity of a light with the thickness of the solution is directly proportional to the concentration of a solution. Here, di by dx, it is nothing but the decrease in the intensity and of a light, and the dx is the thickness of the solution, and the c is the concentration. So this is the final expression. Okay, next, Lambert's law. When the monochromatic light passed through the solution, a decrease in the intensity of a light with the thickness of the solution is directly proportional to the intensity of the incidence light. Same as usual, di is decrease in the intensity of a light and dx is the thickness of the solution, and io is the intensity of the incident light. These both are same, but the difference is only here the concentration of the solution, and here comes the intensity of the incident light. That's it, same. Next comes Beers-Lambert's law. This is the third one, like similar. These three are a very similar one. Law and Lambert's law and the Beers-Lambert's law. These three are very similar. Let us start this Beers-Lambert's law, and the derivation is important for a 4 or a 5 marks, so you need to prepare for it. When the monochromatic light is passed through a solution, the decrease in the intensity of a light with the thickness of the solution is directly proportional to the intensity of the light and the concentration of the solution. Di by dx is directly proportional to I into C. Intensity of incident light and concentration of the solution is I into C. So let us start now the derivation. Okay, let's start now the derivation. Is every terms are clear for you, or shall I repeat it once? Okay, I'll repeat it so we don't need any further confusion. Di is the decrease in the intensity. Okay, dx is the thickness of the medium. I is the intensity of a light, and C is the concentration of the solution, and K as usual proportional constant. If you know these terms, these definitions will become dead easy for you. So concentration should be here, then automatically you'll get to know this Beers-Lambert's law and the Lambert's law. Let us start now the derivation. Okay, now this is the Beers-Lambert's law expression, which will be our first equation. Second equation will be this. We need to remove this sign and right here is equal to, this will be our second equation. Then minus di by I is equal to kc dx will be our third equation. Now we need to integrate the equation number 3 with the integration of I equal to I naught at the x is equal to 0 and I equal to I at the x is equal to x. Integration of I, like here limits, and I equal to I naught, I equal to I naught, and minus di by I equal to k, proportional constant, and the concentration of the solution, integration x is equal to x and x is equal to 0 dx. After integration sign goes and comes ln. Ln is nothing but log. Minus sign as usual carried here. Ln I divided by I naught is equal to kcx. Ln I by I naught is equal to kcx. Minus sign goes. Ln is nothing but log, and what is the value of a log? 2.303 is the value of a log. Ln 2.303 log I naught by I equal to kcx. Log I naught by I equal to k 2.303 cx will be our fourth equation. Okay, k 2.3 will be our e, and log I naught by I will be our e. So let us arrange it. What will be the final equation? The final equation will be a equal to ecx will be our final equation. Okay, after Beers-Lambert's law, the deviation of a Beers law is also another important concept which may come for a 4 marks or a 5 marks. So let us see. Let us draw a graph, and from the origin we will draw a line, and this causes the deviation. Okay, now this will be the concentration, absorption, and this will be the negative deviation, positive deviation. This will be our linear, and this will be our non-linear. Here the adsorption is directly proportional to the concentration. A is directly proportional to the concentration. So, namely, the deviation are of three types. Which are those? Let us see now. These are the three types of the deviation: real deviation, chemical deviation, and the instrumental deviation. The real deviation, I naught is nothing but intensity of the light. The high concentration passes through the tube. The speed of a light is more reduced. Another sample. This is the sample 1 and the sample 2. Real deviation, we are taking the two samples. This is the first sample in which speed of a light is more reduced. In second sample, same everything will take, but it has a low concentration. Okay, then what will be the outcome? The outcome will be the speed of a light is less reduced, and this is the point of the real deviation. The velocity of a light is not same for a second and the first and the second sample. Okay, next comes our second deviation, which is a chemical deviation. It is due to chemical change like association, dissociation, and the pH change, etc. in the adsorption medium. This will be the equation of it. You need to write. This carries 2 marks, or in examination they may ask you explain or what is the real deviation or chemical deviation or instrumental deviation. Among these three they can ask any one for 2 marks, or they may ask for 5 marks directly. Explain the deviations. Okay. Next comes our last, instrumental deviation. It is due to the polychromatic radiation which leads to negative deviation. Monochromatic light used to present this. This is our graph both, and the difference in this is it has a large bandwidth. See, you can observe here. This is the large bandwidth and it has a narrow bandwidth. So it has a 560 nanometer of a space something, and it is also in the same 560 nanometer. So thank you. Do like, share and subscribe.